Welcome, GeoTrig. This is section 6-2, Properties of Parallelograms. The essential question is, what are some relationships between the sides and angles of parallelograms? Let's go. So we'll start with some vocabulary. One vocabulary word here is consecutive angles. These are angles of a polygon that share a side. So B and C here would be consecutive angles because they share this side right here. A and D would be consecutive angles because they share this side. It's two sides, two angles that are next to each other. Alright, so what is a parallelogram? Well, if you don't remember, here it is. It's a quadrilateral, that means it has four sides, with both pairs of opposite sides are parallel. So these two sides are parallel, and these two sides are parallel. That's why we got these little triangles here. Double triangles, single triangles. That's a parallelogram. And these notes, we have a few different properties in these. There are four of them. This is what I suggest you do. You do like two columns right here. We have our four properties, and do little diagrams showing you the properties. So I'm going to rifle through them right now. So the first one, what does this theorem say? It says a lot of words up here, but basically, in short terms, opposite sides are congruent. So for this diagram up here, which I'd put in your notes, this side right here, BC, is congruent with AD, and BA is congruent with CD. That's property number one. Property number two, in a parallelogram, consecutive angles are supplementary. It means they add up to 180 degrees. So consecutive angles, that was that vocabulary word. It's angles next to each other. In a parallelogram, that would mean measure of angle A and measure of angle B adds up to 180 because these are consecutive. B and C adds up to 180. C and D adds up to 180. And A and D add up to 180 degrees. All right, number three. In a parallelogram, opposite angles are congruent. So when you say opposite angles, they're kind of the opposite corners of each other. So A and C are opposite angles, B and D are opposite angles in this. So they will be congruent. So B is congruent with D, angle A is congruent with angle C. All right. And the last property, in a parallelogram, the diagonals bisect each other. So a diagonal is a line going from one vertex to the opposite vertex. So just like this, there's two diagonals in a parallelogram, and they will intersect, and they form a little X. So the diagonals bisect each other. So that means in this case of this parallelogram up here, the segment BE, if E is where they are concurrent, BE is congruent with DE, and AE is congruent with CE. So they bisect each other. That's being bisected, and that's being bisected. All right, those are our four properties. Now another thing, this is in this section. So theorem, if three or more parallel lines cut off congruent segments in one transversal, then they cut off congruent segments in every transversal. So basically you have a transversal and they have congruent segments. So this is a transversal and hey, these are congruent right here. Well, guess what? That means any kind of transversal will also have congruent segments where they're cut off. Why is this even in his section? Because the proof of it is you have to use parallelograms. So I guess it fits right here. Just wanted to show that to you. Let's do some examples. So example number one, pause the video. All right, what is the measure of angle P and parallelogram PQRS? Notice, instead of doing like a triangle, they do a parallelogram shape. It's parallelogram PQRS. That's kind of neat. So, measure of angle P, well, what do we know? We know measure of angle S equals 64. So if S is 64 and P is a consecutive angle with S, then I know that measure of angle P plus measure of angle S equals 180. And if measure of angle S is 64, I know measure of angle P plus 64 equals 180. And I subtract 64 on both sides. And what you're going to get is measure of angle P, cancel, cancel, equals 116. And that's my answer. Next one, pause the video. All right, in the figure, AE is parallel to BF, which is parallel to CG, and parallel to DH. All parallel lines, up and down. AB is equal to BC, is equal to CD equals 2, so all these equal 2. I'm going to write that in here. And EF equals 2.25, so 2.25. What is EH? EH is this entire distance here. Well, we know from that theorem right here that if one transversal gets cut into congruent segments, then any transversal is congruent. So since these are congruent segments up here, guess what? These are going to be congruent segments. So this is 2.25 and 2.25. So E through H, what is EH? That's going to be 2.25 times 3. So what's that come out to? 6.75. And that's your answer. All done.